In this example, we will solve a quadratic equation by using the square root property. What we're going to do is rewrite this to solve for an x squared term and then take the square root of both sides. Now, sometimes the problem's easy because it tells us to use the square root property, but you also want to get to the point where when you see a quadratic equation, you can recognize what the easiest approach is going to be to solve. You could really spin your wheels trying to factor this and solve that way, but that's not going to be the easiest way all the time. In this case, because there's no linear x, or in other words, there's no x, it's not 3x squared plus something x, like 2x or something, plus 54. Because I could isolate the x squared term by subtracting 54 from both sides and then dividing both sides by 3, that's how I know that this is going to be the easiest method to use. So I'd have negative 3 goes into 54 18 times, so x squared equals negative 18. So once again, what have I done? I isolated this x squared term by moving the 54 over, so I subtracted 54 and then dividing both sides by 3, and I get x squared equals negative 18. So that's the first step, solve for x squared. Once I have this solve for x squared, put the square root property is to take the square root of both sides, but don't forget, when you apply the square root property, we have to do the plus or minus. Let's talk just a minute about that. Why do we need the plus or minus? Could we do an easy example like this? If x squared equals 25, and you're just thinking, what could I multiply by itself to get 25? So both boxes have to have the same thing in it. The 5 might come really easy to you. You'd say, oh, 5 times 5 is 25. But do you see that we could also do a negative 5 times a negative 5? So x isn't just going to be 5. It's 5 or negative 5. And that's going to go the same way with any value that we put here where it's x squared equals something. So that's why we're going to use the plus or minus. Now the square root of a square or the square of a square root, they undo each other because they're inverse operations. So we're just left with an x on the left, and on the right, it's correct to say that x is the square root of negative 18 or the opposite, the plus or minus, right? But that's not simplified yet. There are two things I need to simplify. One is that I can take out a 9, the perfect square 9. 18 is 9 times 2, and 9 is 3 times 3. So one thing I need to do is I need to remove that 9. Let me show it to you like this. That square root of 18 would be 9 times 2. So I could remove that 9 from the radical. Or maybe it's easier for you to remember how to simplify radicals by seeing all the factors, the prime factorization. So we'd have a 3 times 3 times 2, and because it's a square root, when I get a pair, it can be removed from the radical. So we have 3 times the square root of 2. And then this negative, the negative means that we have an I. So putting all that together, we'd have this x equals plus or minus the square root of negative 3 times 3 times 2. So x is positive or negative. Let me take them one part out at a time. This negative comes out as an I, and a pair of 3's comes out, and then what we're left with is the square root of 2. So the proper way to write this would be positive or negative 3i square root of 2. Or if it's necessary, you could write it as 3i square root of 2 comma negative 3i square root of 2. That's what that plus or minus means. I hope that this example of applying the square root property, especially with a complex answer, an answer with a negative in the square root, so we get an I. Hope that this example has helped you. But again, what was the process? Isolate the x squared. After the x squared is isolated, do the square root of both sides, remembering that it was plus or minus, and then simplify the radical.